fire ignites passion and creativity. Free your imagination with the slim, sleek, and beautiful new Huawei P8.
The sun works hard on this desert campus.
We get 50% of the total electricity load during peak days from solar.
With support from the National Science Foundation, Arizona State University electrical engineer Christiana Hansberg directs Quantum Energy and Sustainable Solar Technologies, or QUEST. They're tackling what's called the Terawatt Challenge to harness renewable energy on a massive multi-terawatt scale, eventually enough to power the whole planet.
So our approach to addressing the Terawatt Challenge is to make new photovoltaic devices that are both lower cost and more efficient. Modern society is very much defined by its access to electricity. So if we can develop sustainable energy technologies, then we can give access for everybody to electricity in a way that's economically better, environmentally better, socially better.
The team at this engineering research center aims to create new materials that will vastly improve the performance of photovoltaic cells.
This is a molecular beam epitaxy. So generally for the research devices, what we want to do is make new materials that have properties that you can't find in nature.
The Quest site is large enough for constant testing of this industrial-sized tracking solar concentrator. Devices like these may be the cheapest choice for utilities in sunny regions. Stuart Bowden, who heads silicon research for Quest, says while the new technology is cutting edge, some of their methods are, well, easy as pie.
So for this process, we're turning our piece of silicon wafer into a solar cell. So we have metal on the wafer, and what we need to do is fire the metal. So this is kind of like a big pizza oven. And here it comes out. And we now have our finished solar cell.
In this photoluminescence room, they use yellow light to look for defects in solar cells.
So if we take this wafer and then bend it, we'll find that it shatters pretty quickly.
We're always trying to make solar cells cheaper and cheaper. Can we come up with processes where we just take the silicon and we make it flexible, we can make it lightweight. So this would improve the ways that we could install silicon solar cells.
The Quest team also wants to sharply ramp up efficiency. They say a standard solar cell is now 15 to 20% efficient, but they believe it will one day be possible to go to the thermodynamic limit of 87%. But even now, they say solar energy is ready for prime time.
Now, in many, many places, photovoltaics is actually lower cost than what you pay for the grid.
A hot idea, putting the power of the sun to work, keeping the lights on, the environment clean, and your money in your pocket.